This is a set of tools a friend of mine made for me that are based on the BMW tools for disassembling and removing the bearings on the shafts in the transmission. This and this are used to work on the input shaft, and this are also used to drive the seal onto the input shaft. And then I have a couple of drifts that I can use to push the shaft or bearings as I need to. It's a nice kit, and really want to say thanks to Bill Lambert, who's the gentleman who machined this for me. Besides the BMW transmission tools, I need the rest of this to assemble the transmission. This is a flat plate that I got from CycleWorks. Comes with 4 Allen bolts that attach it to the top of the case, and it's machined dead flat, and then it fits over the bearing races, and I can use it to measure the depth from the top of the plate to the top of the bearing races, which is part of how I figure out how much shimming to put on the tops of the ball bearings to give me the end play I need. To do that measurement, I use a depth micrometer, and that has an anvil that pushes down, so it measures a depth, and I use that on the top of the plate to measure the distance between the top of the plate and the top of the bearings. And I also use it to measure the distance of the pockets in the rear transmission cover. To measure shims and other items like the exact thickness of the plate, I use a micrometer that measures down to a 10,000th of an inch, which I think is important for getting the proper shimming. Now, to install the output shaft seal, I find that an old crankshaft bearing is a pretty good diameter that fits the seal nicely. And then the other tools I need are the tools I used to remove the output shaft flange. I use these tools to install it, and I got this from CycleWorks also. So there's a number of other things you need to have on hand, particularly precision measurement tools to assemble the transmission correctly. To prepare the shift forks for assembly, I polished up the shaft and also took a brass brush and my parts washer to clean out the inside of the fork. And then I took a drill bit and wrapped some 600 grit paper on it and gently buffed the inside of the fork, and then came back with 1000 grit and did the same thing so that they're nice and shiny and smooth. That improves shifting because the forks have less resistance, so they slide rather easily on the shaft. Now, the intermediate shaft fork I did the same thing to, and I also polished up the shaft inside the housing that fork slides on, and so that's kept everything nice and low friction. So this is the neutral switch, and it has a washer that's just the right thickness, so when it's installed, the push button on the switch will be right where it needs to be on the shift cam. Now, there were 2 styles of these switches. The earlier one is normally open, which means that when the button's not depressed, nothing flows through the switch. These later style are normally closed, and that means when the button's not pushed, current does flow through the switch. So you want to make sure you install the right neutral switch for your model transmission. Now, I want to just check and make sure the switch is good. So I have my voltometer on auto, and you can hear it's beeping, and when I push the button, it stops. So with the button closed, the switch is open, and with the button not closed, the switch is closed. There's a baffle for providing more lubrication to the output shaft bearing, and that's this bearing here, and this end fits in the bottom like that, and then there's a screw that runs through the top of the case to secure that. Now the screw should have a fiber washer, and in the rebuild kit I got is a metal washer in case that one's degraded, but mine looks pretty good, so I'm just going to continue to use it. So I'm getting ready to assemble the transmission, and I'm going to start by heating the case to 275 to 280 degrees in the oven. And then I've laid out all the parts in the order of assembly. Now, inside the case is the bore for the input shaft, and for the intermediate, and for the output shaft. The output shaft bearing is bigger than the intermediate. So when I get the case hot, the first thing that's going to go in is the roller bearing on the input shaft, and then the baffle plate on the intermediate shaft, and then the larger baffle plate on the output shaft. This is the intermediate shaft, and I have the shift fork already inserted, and I lubricated the fingers of the fork and the shaft of the fork and the groove in the gear already. So I'll put that in and engage the shift fork on the shaft here, the stub shaft. Then I'll install the output shaft and mate the gears with the intermediate shaft, and then slide the two bearings into the bore. Next, I'll insert the output shaft shift forks and shaft and engage the fingers into the appropriate gears. Then I'll engage the ends into the cams on the shift cam plate and get that so that it's aligned, and then tighten up the bolts and torque them to hold the shift cam assembly in. These need to go in while the case is hot because they're an interference fit. And then last, I can slide in the output shaft and engage the helical gear with the helical gear that goes here on the intermediate shaft. So the case is out of the oven. Start to drop it in the bearing, and it drops right in. The intermediate shaft baffle and the output shaft baffle. Then I'm going to slide, notice the long end of the fork points down, and fifth gear is the helical gear. I'll slide that in and push this intermediate shaft out of the way, and then bring in the input shaft and mate the gears with the intermediate and line everybody up, and they're in there. Let's make sure they're seated. Now this is the fork assembly, and the bottom fork arm has the kink in it. So I'm going to slide this in and then get the forks on the proper parts of the shaft, and then align the fork shaft with the hole and press it in. Okay, that's all in. Now I set the shift cam assembly on neutral, and I'll align the pins into the cam, And I have to kind of pick up this finger a little. This is not as easy with your gloves on. Helps if I get things better aligned. And I got that. That's the bottom one that's fighting me. Okay. I got the bottom one to slide into the cam. Okay, so now I'm going to hold that with this hand. Oops, it slid. Okay. Try to keep everything in one place here. Okay, so now the fun part is to flip the transmission up so that I can get the bolts in that hold the shift cam plate in place. Okay, check. Yeah, everybody's still engaged. Okay. So now I'll just tighten up those bolts. Now this one's not quite there. There it goes. Still not quite there. It's a very precise fit, so you have to rock the cam plate just a little bit to get the threads to line up. There we go. It's getting in there now. Okay, then these get torqued to 14 foot-pounds. And that's one. And that's the other. Okay. One more time just to make sure the shafts didn't shift. And we'll just let it cool off. Well, the last thing I'm going to do is install the input shaft. And of course I need to have my transmission centered so that the hole in the board is where the shaft's going to go, and I don't think that's the case at the moment. There it is. Yeah, once I got the hole for the input shaft lined up on the board with the shaft, then everything's where it needs to be. Now that the transmission's cooled down, I want to check to be sure I can shift through the gears. And since I haven't put the rear cover on, the bearings are not tight. They can wobble. So I'm going to use this plate that I got from CycleWorks, and it's the same plate I use to measure the depths of the bearings so I can set the shimming for the proper end play. But it works to immobilize the gear shafts just like the rear cover would. So that's a good way to do a test of the shifting, because you need all of the shafts to be in the proper alignment. So I'm just going to lay in the top plate and the supplied Allen bolts that fit into the case, and then I'm going to try to shift the transmission by rotating the shafts. I'm going to use the output shaft and use the transmission gear shift lever to see if I can get it to shift through the gears. And it's always a little hard because not everything's quite where it needs to be. Okay, that's first. There we go. I need to push that in a little further. That's fourth, and I think that's fifth. So it's going up through the gears and down through the gears. So that's good, because that means the alignment of the shift cam assembly with the shift forks is correct, and the whole mechanism is working. This is a precision depth gauge that I'm going to use to figure out how much shimming I need to get the end play on the transmission shafts to be correct. And before I use it, I want to calibrate it. So I have a machine flat surface, and I'm going to put it on it and then bring it down until the ratchet clicks. And then check my measurement. This time I'll lock the setting, and I've got it exactly on 0, so I don't need to adjust my depth gauge. It's calibrated. Transmission shafts for end play, I need to measure the depth of the pockets in the rear cover. So it's the distance from the top to the shoulder here inside that I need to measure. So I use some soft jaws in my vise to just kind of hold the cover, and it makes it a little bit easier to do the measurements. And then I use my depth micrometer and measure the distance down from the top to the shoulder. And I'll take about 3 of these just to be sure I'm getting the same measurement. Then I make 8 equally spaced measurements around the bore. And then I average those and use that average as the depth for each of the shaft pockets in the rear cover. Now, when you're measuring the depth of the pocket in the cover, right here is a fillet, so it's slightly higher at the very back than it is at the very front. So what you do not want to do is take your measurement with the anvil up against the back like that. what you want to do is pull it out so it's actually hanging over a little bit of this outer edge, and then take your measurement and you'll get a true measure of what the shim is going to have as added height. Now when you look at the shims, they're a little smaller than the holes in the top cover, and you can see there's a slightly shiny area toward the front edge and then darker in the back. So the shim's really been riding along the shiny edge here, and again, that's why you want to take your measurements closer to this edge than you do up against the bore. So I'm ready to measure the height of the bearing outer race from the edge of the case. And I've installed the gasket, which by the way only goes one way, and also the CycleWorks flat plate, which is machined dead flat, and I've attached it with the included 4 Allen bolts and then torqued them to 72 inch-pounds, which is the torque setting for the case bolts. Now the first thing I'm going to do is zero my depth micrometer. So I place it on the plate and then turn the ratchet until it clicks. And I'll check it again, but it's right at 0. So I don't need to adjust the depth gauge. And then what I'll do is take a number of measurements. In fact, I take 8 measurements for each bearing, equally spaced around, to see what the depth is, and then I average those measurements. And so what I'll do is run the anvil down while holding the depth micrometer flat on the case with 2 fingers until the ratchet clicks. And then I'll check that a couple of times to be sure I'm seeing the same reading on the scale. And then I'll record that in my spreadsheet. And as I said, I average all 8 for each of these as part of my computation of how much shimming I need to put on the top of the bearings to give the proper end play for each of the 3 shafts. So I finished all the measurements and selected my shims. And I just put them in a bag to make sure I get the right shims on the right shaft. And then I'll remove the measuring plate, put the shims on the top of the respective bearing, and then put the rear cover on. So I'm getting ready to install the rear cover, and I want to put the shims on the bearings. What I do is take them out of their little bags, which I put them in when I measured them. And this is the intermediate shaft, so it has the baffle plate, which fits on like that, and then the 2 shims. And I like to put a little bit of grease on the shims to keep them from moving while I put the cover plate on. It's just about sticky enough to keep them stuck where I want them. And then the output shaft shims go on this bearing. It's important when you install the shims after your measurement that you don't mix them up. So that's part of the reason I put them in bags and very carefully place them. There we go. So they go on like that. So they're all on, and then I'll put the heated cover on and then tighten up the 9 case bolts to 72 inch-pounds while the cover is still hot. Before I install the cover, I want to install the output shaft seal in the cover. And I oiled the outside of the seal, and it goes in with the back facing you. And what I found is if the cover's hot, it goes in a lot easier, and I've used an old a crankshaft bearing, and then I can just tap this down. and make sure that's seated all the way. And then I just put the cover on straight down on the pins. There's a pin here and a pin here. And make sure my gasket's in place. And my shims are where I want them to be. And just sort of slide it straight down without trying to, try not to move the shims. I don't want to crease any of them or bend them when I put the cover on. There it goes. Now I'm just going to tap it with my hammer. Okay, the cover's on, and I'll just run in the bolts. Whoops, dropped that one. I'll just run in the bolts and tighten them up and torque them to 72 inch-pounds. The other thing I'm going to do is just wrap on the input shaft and make sure it's seated in the top case, and then I'll torque all my bolts now that I have them in. Now the next thing to install is the input seal, and I'm using the seal driver, which has an inner and an outer part. I lubricated the inside of the seal and carefully slid it onto this drift. And the drift protects the splines from cutting into the seal. So it just goes on like that. And then the outer drift fits over and you just pound it in. And there it is, all installed and no damage. Now the gear shift shaft seal fits in here, and I use this little drift, and I oiled the outside and the inside of the seal, and then that will hold it just like that, and I can tap it in. Okay, there it goes. So all of the seals are in the case. So I'm ready to install the flange on the output shaft, and I clean the inside with brake cleaner, and before I put the cover on I cleaned the taper on the output shaft with brake cleaner. So I'll put this on, and then the thick wave washer and the nut go on, and then I torque that to 160 foot-pounds. Now to torque it up, I'm going to use the flange puller tool, and when I put the flange on, I push down on it, and if it's on there correctly, you can't pull it up. It's stuck. That means that the taper on the output shaft and the taper on the flange are completely clean. There's no contamination or oil on those surfaces, and that's really important. Now to tighten it, I'm going to use the same trick I used to take it off, which is put my feet on this old fork tube and then pull to torque it up to 160 foot-pounds. Oh, there it goes. Okay. Now I'm ready to install the speedometer gear, and that's the end that goes inside, and it'll engage with the helical gear on the output shaft. And then the bushing has a slot which will line up with the hole here. And then this is the special breather bolt with the hole bored all the way through it. And I ran a piece of wire through to be sure it's clear. Now the flat washer goes on the bush, and then the wave washer's under the head of the bolt. And if the bushing is turned so the slot's in the right position, you can tighten up the breather bolt just like that. Okay. So I'm ready to install the neutral switch with the washer, and it sometimes these will crack between the aluminum and the phenolic. So a couple of years ago when I bought this new switch, I used some Plastade, which is a kind of a cool material, and built a cap all the way around. So far it's holding up, so I'm going to continue my experiment with that. Now this just screws in, and then it's a 19 millimeter to tighten it, but you don't want to get ruthless, because if you really tighten this too hard, that's what cracks the seal between the case and the phenolic. So it's snug like that, and that should work.